Hey everybody, here's the review that's in the packet that you have. So we're going to go through this and I'm going to talk about each thing and make sure that you understand each part of these polynomials. So when we look at this first one, when we put it in standard form, we have to scan through and find the highest power first. So the highest power here is x to the fourth. So that's what we have to write first. So we have our 12x to the fourth. When I look here, I see that my third degree of x is next, so the entire term goes with it. The negative 6x third, and then finally is a negative 6x squared. Now when I go to classify these, I have a couple choices. If I'm classifying it by my number of terms, I have three choices, actually four. I call it a monomial if there's one. I call it a binomial if there's two terms. If there's three terms, I call it a trinomial. And anything more than that, we just use the phrase polynomial. I won't be lazy. Okay, so then when it comes to classifying things by degree, we want to go ahead and get these terms down too. If I have just a plain constant, that's when I have x to the 0 power, which remember we don't actually write. We instead just have x to the 0 power is 1, so it's just a constant. If we have x to the first power, we call that linear. X to the second power, we call that quadratic. Anything to the third power is cubic, and anything beyond there, we just say to the fourth power, to the fifth power, something like that. Now we only do this by the leading term, which is why standard form is so important, because once I see this, one more, quartic, Q-U-A-R-T-I-C, which happens to be Q-U-A-R-T-I-C, happens to be this one. When we talk about its other classifications, because I see 1, 2, 3 terms, I'm going to call this a trinomial. And our leading coefficient is going to be 12. That's the coefficient to the highest term after I put it into standard form. Okay, let's check out number 2. 6th power, 12th power, 9th power. So this 12th power term is going to come first. And remember, everything comes with it, the coefficient and the sign that introduces it. Negative 9x to the 12th. My next is going to be negative 3x to the 9th. Then I have positive 5x to the 6th. And here this 16 is our first example of a constant. No x's. Or x to the 0 power, which is the same as 1. All right, when I classify it, I see 1, 2, 3, 4 terms. So I'm just going to call this a polynomial. My leading coefficient is going to be that coefficient on my first term, so negative 9. And my highest degree is my 12th degree. I don't have a fancy name for that, so I can just call it the 12th degree. All right, now something that looks so simple, like a 12, we have to be a little careful about. So here, let me zoom in a little so you can see a little better here. There you go. So when we look at a 12, our standard form is obviously going to be 12. When we look at how many terms it has, that's a monomial. One term. The leading coefficient, it really doesn't have, or we can call it a 12. if we wanted to imagine, and I'll do it in a light color, if we wanted to imagine, pencil, we could say this is x to the 0 power, which again we know is 1. So it really doesn't matter. When we're talking about the degree, that is our constant. Alright, so you try this next one and check back with the video and see how you do. So hit pause. How'd you do? So standard form, my x to the 7th, all 43 of them will come out to the front. That's a binomial because there's 2 terms. My leading coefficient's 43. And it's to the 7th degree. Okay, so this goes back to what we did when we were still in class together. When we're talking about simplifying by adding or subtracting, our goal here is to combine all of our like terms. If I see a plus sign, I don't need to worry about distributing the sign because it's this big thing plus this big thing. No problem. If I see the subtraction sign, it changes everything because it's this big thing minus this thing. So we'll talk about what happens with that sign in a minute. So you're going to look for same variable, same power. If I have 2x squareds here and 1 here, that's going to give me 3x squareds. If I have 7 x's and somebody takes 2 of them away, I'm left with 5 x's. 1 plus 8 is 9. So this is standard form because I've combined all like terms and nothing else can be simplified or combined. So what I'm going to do here with this next negative is this negative is taking away my 2x cubes, it's taking away my 9x squareds, and it's taking away my 2. So I can cross this out and recognize that now I've distributed this negative. These parentheses are not really necessary anymore, so I can go ahead and combine like terms. Same variable, same power. Taking away 4x cubes, taking away 2x cubes means I'm taking away 6x cubes. Taking away 14x squareds. Adding 2 x's, and I don't have any more x's here, so I'm adding 2 x's, and then there's my constants on the end. So what I wind up with is a cubic, because my highest power is to the 3rd, and it's a polynomial because I have 4 terms. All right, let's look at my last 2. Again, with this subtraction, I'm going to take away 4m squareds. I'm going to take away 10m's. And notice when I take away a negative, I wind up adding it. So I distribute that negative to each of my terms. So if I have 7m squareds and I'm losing 4m squareds, that's going to give me 3m squareds. Losing 3m's, losing 10m's means I'm losing 13m's. Adding 5, adding 9 means I'm adding 14. Okay. So for my next one, I'm adding, so these parentheses end up not really mattering because everything is addition. So I can just look at the sign in front of each term. 5a cubes, 1a cubed gives me 6a cubes. Taking away 1a squareds, taking away 4a squareds means I'm taking away 5a squareds. Adding 3a's, adding 1a, I'm adding 4a's. And then my last term, of course, my constant is going to be 3. I want to double check and make sure I got everything. That's positive 6, negative 5, my positive 3 plus this 1, a's, and then there's my 3. All right? So I've added my polynomials because I'm combining like terms. Sound okay? Let's go on to the next. All right, so for this one, I'm asked to find the product, which means I know I'm going to be multiplying. Now, these first couple ones are no problem because I don't have 2 algebraic expressions. I only have one coefficient that needs to be distributed. Here I have a coefficient and a variable that needs to be distributed. It's not until I get down here do I have to worry, because these plus and minus signs are what means I'm going to have to, for these, use either my FOIL or my box or my bow tie method. So remember we talked about those 3. Okay, so when I find the product, I need to distribute. So that becomes 5 times x plus 5 times 8. So it's 5x plus 40. I distributed this and I've simplified it. When we simplify, that's when we're removing the parentheses. All right, so I'm going to take 4x and I'm going to share it out to each term. So that's 4x times another x minus 4x times my 9. So I'm going to end up with 4x squared, because x times x is x squared, minus 36 x's. 4 times 9 is 36, and then I have that x. I've simplified it. I've removed the parentheses. All right, next up. This 7x cubed has to be distributed to both terms inside of this algebraic expression. An algebraic expression is when I have the parentheses and the plus or minus sign. So that's 7x cubed times 2x squared plus 7x cubed times x. That's going to give me 14 x's. Now I have same base add, so I have 3 x's as factors here and 2 x's as factors here, which is going to give me 5 total x's being multiplied, plus 7x, here's 3 factors of x, 1 more, and that makes x to the 4th. All right, so those are my easy ones. Now comes the ones where I'm going to multiply together, and I'm going to make sure that I multiply everything by everything else. So I'm going to multiply my first terms, x times x is x squared. My outside terms, x times negative 1 is negative x. My inside terms is going to be 8 times x. And my last term is going to be 8 times negative 1. So there's that moon shape that I see from my shapes. Here's my first and my outside and my inside and my last. X squared plus 7x minus 8 is the polynomial I get when I combine my terms. Now, if you were a fan of the box method and you thought that helped you keep everything organized, you can always use your box method too. So if I go to put my values in the box method, I have x plus 8 and x minus 1. Here's my x squared. Here's my 8x. X times x is x squared. 8 times x is 8x. X times negative 1. 8 times negative 1. And you'll see I get the same thing. X squared. Here's my like terms that I add together. So it doesn't matter how I do it, I get the same answer whether I do it through FOIL or whether I do it through the box. Okay, so in the notes we talked about something called a special pattern, and this here is a special pattern because I see the same numbers, 4n, 4n, 7 and 7, but this one is a sum and this one is a difference. That's why we call this pattern the sum difference pattern. a really cool thing is going to happen when we multiply the values of a sum difference pattern. When I do my first terms, 16n squared, my outside terms minus 28n, my inside terms plus 28n, and my last terms minus 49. Now here's what we begin to see. Guess what? These are a zero pair. Plus 28 and minus 28n's are going to cancel each other out, and they're going to create that zero pair. That always happens with the sum difference pattern. So my answer is going to be 16n squared minus 49. Guess what? Our answer even has a special name. We're going to call this answer the difference of two perfect squares. And that's going to be real important on our next unit, so hold on to that idea. All right, nothing fancy about this one. We can go ahead and do our FOIL, our first, outer, and inner, and last. Our first terms are going to be 27m squared. Our outside terms are going to be 9m. Our inside terms, negative 12m. And our last terms, minus 4. Here's our like terms to combine. So we have 27m squared minus 3m minus 4. I combine those middle terms. They are same variable, same power, so I can put them together. Doing okay so far? All right, ready for the most missed problem? It's this next one. So if you're worried about falling into the most missed trap, go ahead and rewrite this like this, because I guarantee then you'll remember to FOIL. And do your first terms, your outside terms, your inside terms, and your last terms. First terms, outside terms, inside terms, last terms. Whenever you have two identical binomial factors, you're always going to end up with a double on the inside. And that's a special pattern for us to remember. So we end up with a square as the first term, a double as the second term, and a square as the last term. So our first, outer, inner, last will give us this square, double square pattern. Now, here's what I want you to not do. And I'll say, do not do. Sometimes people see this and they make this mistake because they think it's just x squared and 9 squared. No, no. That is the most missed. If you look at, you forgot your whole middle part, and you can't have that. All right. Don't be surprised if you see fractions. Do not be afraid of the fractions. Take it slow. You can do it. Your first terms are going to be 1/2 x times 8, which gives me 4x squared. 1/2 of 8 is 4. X times x, x squared. 1/2 of negative 6 minus 3x. This is going to be plus 32x. 4 times negative 6 is minus 24. Now, if I'm going too fast for you, you need to learn your math facts. So go on my Blackboard site, play some games, get better at it, because you need to be able to do this multiplication as quickly as I am doing it. 32 minus 3 minus 2 takes me back to 30. One more puts me down at 29 x's. minus 24. All right, let's keep going. 3w squared minus 9. Now this one's interesting because it already has the squared here. So I know I'm going to end up with that times w. I'm going to have a cubed variable for this one. So 3w squared is going to be multiplied by 5w. That's our first term. And then plus 3w squared times negative 1. That's going to be our outside term. Our inside terms are going to be negative 9 times 5w. And our last terms are going to be negative 9 times negative 1. Now it's easy to get tangled up in these negatives. So let's do some simplifying. This is 15w cubed. Oh, it's going to be minus 3w, because this times that's going to be negative. Minus 45w. And it's going to be plus 9, because a negative times a negative is a positive. Alright, so now I'm going to combine my like terms here. And I'm going to get 15w cubed. Oh wait, these are not like terms. I forgot my squared. 15w cubed minus 3w squared minus 45w plus 9. Guess what? There's nothing to combine on this one. And the reason is because this squared gave us a cubic, a quadratic, and a linear term all together. All right, so let's talk about 18. This negative has got to be distributed to everything. So this is going to be negative 12. And I have 2 x's here, 3 x's here, which is going to give me 5 x's. Plus, because a negative times a negative is a positive, 11x, 2 x's here, 2 here, gives me 4 x's as factors. Minus x squared times 3 is 3x squared. Alright, so for this next one, I have a trinomial. See how there's 1, 2, 3 terms? So sometimes kids like the box method for this. So we'll show you the box method one more time. So we'll go ahead and draw our box. And we'll draw this one extra long because guess what? We have 3 terms in one of our factors. We have an x squared, a negative 6x, and a negative 2. Over here we have an x and a positive 6. So when we go ahead and we do our box method, we're going to multiply each thing times what's touching it on the box. So x times x squared is x cubed. X times negative 6x is negative 6x squared. X times negative 2 is minus 2x. 6 times x squared is 6x squared. 6 times negative 6x is negative 36x. 6 times negative 2 is negative 12. X cubed. Check it out. Here's my squared like terms, and here's my linear like terms. Positive 6x, negative 6x. Hey, isn't that nice? It's a 0 pair. Negative 36x's, negative 2x's is negative 38x's and minus 12. Next one up. 4a minus 2b. Would you like to do the box method for this one too? Sometimes the box method is nice because we guarantee that everything gets multiplied by everything else. So we'll put 4a and negative 2b on this side, and we'll put 3a and positive 5b on this side. All right, 4a times 3a, 4 times 3 is 12, a times a squared. 4a times 5b is 20ab. Negative 2b times 3a is negative 6ab. Negative 2b times positive 5b is negative 10b squared. So now when I go to write my like terms together, these both have an a and a b to the first power. Those are like terms. I can combine them. Positive 20, negative 6 is negative 14. Ooh, positive 14. AB minus 10b squared. How did you do? All right, let's check out the next page.